In the Physics.js tutorial, they show a couple examples of adding bodies into the world to render. And the code looks something like this. You say physics.body rectangle. Here's the starting X and Y position. Here's the width and height. Then we tell the world to render, and Physics.js should put that on the screen. Now, even though there's no DOM manipulation in this particular code, and I could certainly inject physics into something like a controller and find a way to get access to world, what I'm thinking is that I could also do this easier if I just had some custom directives to represent physics body. So in shell.html, if I had the ability to write code like this, I want a physics body of type rectangle, and here the starting options is going to start at this X position, this Y position, have a velocity on the Y axis of negative 0.3, and the width and the height. I think that would be even easier than writing this code inside of my controller. But if my controller does need access to this body that's being created, perhaps I can have an expression that says, let's take what Physics.js creates to represent this body and bind it against the current controller objects. We'll bind it as a property called box1. That will give me access to box1 inside of my controller. I think this would be a pretty good solution. Now there's a couple things that have to happen though. As soon as you start having a parent-child relationship in your directives, you have to be careful about a couple things. This physics body is going to create some sort of box, and ultimately it wants to add that box to the physics canvas. But in order to be able to do that, the physics canvas has to be initialized first. It has to have the ability to set up the world, set up the renderer, and then it's in a state to accept objects. But by default, the way we have written physics canvas, we have written it with a linking function. And technically, when you do this with Angular, this is what's known as a post-linking function. And with post-linking functions, they run in the child element first and then in the parent element. That means the way we have things set up right now, physics body would try to create some sort of object and place it into the world before the world has been created. But there's an easy fix for this. Instead of returning a post-linking function to Angular, I need to give Angular what's known as a pre-linking function. And the only way to get a pre-linking function with Angular is to write a compile function. And what this compile function has to do is return an object with the pre and the post link. So I need to return something. And in this case, I just needed to have a pre-member. I need this to go to a pre-linking function. Let me take this function out of the directive definition object because it's going to get a little bit uglier. And I want to make sure that I cut all of the code inside of it. And I'll remove this link member entirely because now we have a compile member. Angular will call that. It will return an object that has a pointer to the pre-linking function. Let me place that here. Pre-link equals a function that still takes scope and element. It's going to go out and find the canvas, set up the renderer, and we're good to go. Now the key part here is that when you build a new object, you need to add it to a world. And that means my child directive is going to need access to the world created by this canvas. And that's something I can do by having a controller for this particular directive. So in addition to the compile member that we just added, let's add a controller, another small anonymous function. What I want to do is expose an API from this controller. So I'm going to add methods to the controller instance. And I'm going to build a method called add because that is the API that I would expect on a world. So I want this canvas directive controller to represent a world. And this.add is a function that takes different types of things. So I'll just call it thing. I just need to get this into the world. How am I going to get it into the world? Well, when we create the world up here in the pre-linking function, what I could do is add that world to my isolated scope object. And down here in the controller step where we inject scope, now I should be able to say scope.world, please add this thing. And with that code in place, it's now time to take a look at how to build a physics body. Remember, we want to be able to specify attributes like type, body, and options. So once again, I have a directive definition object ready to go. I'm going to restrict a physics body to being just an element, and I'm going to require, as a parent, the physics canvas. That should give us access to that API and have the ability to call add on this controller. I'm going to set up an isolated scope for this one, so that I can have binding against that options object and binding against the body. Those are going to be model binding expressions, and then type is just going to be an attribute binding. I don't expect anyone to change the type of an object once it's been created. And all the linking function needs to do is ultimately call add on the physics canvas. So the linking function takes scope, element, attributes, and then the canvas. Unfortunately, we use almost none of those, but we can say scope.body equals physics.body, and this means we have to inject physics. And physics.body is going to take scope.type and scope.options, and that should pretty well simulate the code that we see here in the tutorial. Now we just need to add that body into the canvas. So canvas.add, passing in scope.body. What that ultimately should do is go to my physics canvas controller and add this thing that's been created into the world. Now there's one last little bit that we have to do before we can see this render, and that is to set up a timer and a stepping function for the world. We'll look at that in the next clip.